All right, hello everybody. We are starting section 6-5, which has now to do with operations with radical expressions. So starting off here, we're going to be simplifying radicals that don't come out so pretty, not like the previous section. So it's going to be kind of a big mess, to be honest with you, these first few examples. But I'll show you how to simplify basically any radical. So again, we got square roots, fourth roots, cubic roots. And then we have operations is when, so we're going to be multiplying with radicals. As you can see, then we're adding and subtracting with radicals, and then multiplying once again, foiling, and then the last one is division. Okay, so again, when I think of operations, I'm usually just thinking adding, subtracting, multiplying, dividing. So similar idea. So coming to our first examples, it has the product property of radicals, as you can see. So if you go through, it says the square root of 2 times the square root of 8 is the square root of 16, which is just 4. And then similarly, if you have the cubic root of 3, if you times it by the cubic root of 9, then you get the cubic root of 27, because 3 times 9, which just simplifies to be 3. Okay, so again, we're trying to break down radicals is what we're trying to do, but they're not always going to be exactly what you think. So like for the first one, the square root of 32x to the eighth, right? 32, I can't actually take the square root of it, but I can simplify it. There's a couple ways you can simplify radicals. So if you have the square root, let me just do 24, for example. So square root 24, let me just kind of outline to you guys different ways you could do this. First way, you could just break this down into basically doing the prime factorization. So starting with like 2 times 12, 2 times 12 is going to get me 24. So square root 2 times square root 12 is the square root of 24. So I can stop with the square root of 2. I don't have to break that down because that's prime. But now breaking down 12, this would be 2 times 6. And then breaking down 6, that's 2 times 3. Okay, so here's the prime factors of 24. Now, because it is a square root, you're looking for matching pairs of the same numbers, of the same radicals. Well, here's two square root 2's, and then these don't have a match, so they just kind of stay as is. But when you find your matching pairs, so this is going to get pulled out front as an actual 2, because if you multiply those back together again, that's just square root 4, which again, just a 2 is going to be pulled out front. Okay, because square root of 4 is 2. And then you still have these two left over. You just want to remultiply those back together. So square root of 24 simplified is just going to be 2 with a square root of 6 left over, just remultiplying these back together. Or similarly, you can do something a little bit different. So another way you can simplify the square root of 24, you can break it down trying to find the biggest perfect square that you can think of that divides into 24. So here's your perfect squares. We got 4, 9, 16, because one's not going to be useful, so you want to start with 4, but 4, 9, 16, we got 25, right? 36, 49, 64, so on and so forth. After 64 would be 81. Like I said, so on and so forth. So find the biggest one that we know that divides into 24. So the first one, I broke it up into 2 times 12, but what if I started with, I could have just did 4 times 6, because again, I know the square root of 4. The whole point of doing this is to not have as many steps, because we know the square root of 4, we know what that is, that's just 2, and then I still have square root of 6 left over. So you get to that answer a little bit faster. I think the first way, though, honestly makes more sense in the end, because you might be sitting here for a while if you have a really big number. You know, if you had like the square root of, I don't know, 2,645, something like that, right? You might be sitting here for a while trying to find that perfect square. So you could just break it down, like I said, into prime factors and find matching sets. Okay, so I'm going to show you guys a couple ways. So for the first one, we're taking the square root of 32 and then x to the eighth. Again, I'm just going to break it up because we're taking the square root of each term. So again, 32 I know is not a perfect square, so I need to break it down. So I'm just going to start with, I'll do 2 times 16, 2 times 8, 2 times 4, and that's 2 times 2. Okay, again, we're looking for matching pairs. So here's 2 2's and here's 2 2's. We still got that guy left over. So I'm pulling out 2 2's because I have 2 pairs of 2's. So this again comes out as 1 2. This will come out again as another 2. So these just get multiplied together as well. So if you're pulling out, let's say if this was a 2 and this was a 3, I'd multiply them together and get 6. But I'm just going to multiply 2 times 2. That comes out as a 4. And I'm going to leave some room. Underneath the square root, then we still have 2 left over, so this guy's still left. And then as far as x to the 8th, so we're taking the square root of x to the 8th, well, that should ring a bell from the previous section. If I take the square root of x to the 8th, that's just going to be x to the 4th, with no x's left over. So my answer would be 4 x to the 4th is square root of 2. Okay, that's my final solution set. For the next one, 4th root, so we're taking the 4th root of each and every single term. So I'm taking the 4th root of 16. We're taking the 4th root of a to the 24th. And the 4th root of b to the 13th. So just kind of breaking it up here. 4th root is 16. Double check and see, is that a perfect 4th root? If I take the 4th root of 16, does that simplify? It does. You get 2. Okay, so that's good. Don't have to break that down. Same with a to the 24th. If you take the 4th root of it, that's just a to the 6th power. And now the problem comes with b. Okay, so since it is a 4th root, you have 13 b's, b to the 13th. The question is, how many groups of 4 can we take out from 13? And if you need to, this might get a little tedious after a while, so you should be able to do these in your head once it gets a little bit easier. But I'm taking the 4th root again of b to the 13th, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13 b's. Okay. Again, how many groups of 4 can we pull out? Well, here's 1, 2, 3. Here's one group of 4. 1, 2, 3. Here's 2 groups of 4. 1, 2, 3. Here's 3 groups of 4. And then we still have this guy left over. So this would come out front, these groups, as being b cubed, since we have 3 of them. And then we'd still have a 4th root of b left over. There's your complete answer. Okay, which again, I know it's messy. Key thing too, a lot of things that students always forget, something that's a pretty common mistake, make sure you keep this a 4th root. So the problem starts off as being a 4th root. Make sure you keep that index with it throughout the entire problem. Okay, don't just let it fall off or disappear or anything of the sort. Make sure that it stays consistent. Okay, so the next one for number 3, we're taking the square root now. So we're doing the square root of 12. And then square root c to the 6th, square root d cubed. Okay, so each term from left to right, 12 is not a perfect square, so we got to break it down. I'll just do 2 times 6. 6 is 2 times 3. Here's 2 2's. Okay, so square root, we just want 2 of them. We just want a matching pair. So that's going to come out front again as a 2, and then you still have a square root of 3 left over. So as I start to simplify, 2's out front. Underneath the square root, you still have 3. Okay, I'm leaving that gap there because I still have to simplify c, I still have to simplify d. So let's see how far we get. So if I take the square root of c to the 6th power, that's just going to be c cubed. So that fully simplifies. And then as far as d goes, the square root of d cubed, again, square root of d cubed, well, how many groups of 2 now? So the 4th root was how many groups of 4? Square root, you want how many groups of 2? Well, there's just going to be one group of 2, and then we still have this left over. So I pull out 1d. Again, even though there's 2 of them here, that only represents 1d when you pull it out, and then you still have a d underneath the square root. So 2c cubed d, square root 3d. And the last one, so taking cubic root now. So we got the cubic root of 27, cubic root of y12, and then cubic root of z to the 7th. Okay, so cubic root of 27, if you don't know if it's perfect cube or not, again, just plug it in. I'm doing cubic root, shrink it down, of 27. You should know, though, that it is a perfect cube. That's just 3. So 3 simplifies. The next one, y is also going to simplify, so that's just going to be y the 4th. But now z. Okay, so again, the quick shortcut way, 7 divided by 3, that does not divide too nicely. But now how many groups of 3 can we pull out from 7? We can pull out 2 groups. Okay, that 2 groups of 3 represents 6 of them altogether, where you're still going to have 1z left over. So underneath the cubic root, now you're going to have a z. Okay, what might help too, when you have these indexes, like we do in these problems, it might help to put this inside parentheses, just to isolate it, to know that the radical, again, is different. You still have this index. Again, just make sure you keep that little 3 out front, your index, in your root, but that would be your final answer. 3y to the 4th z squared, and then cubic root of z would be left over. Okay, now quotient property of radicals. So it kind of goes through and outlines using the quotient property. Okay, but keep in mind, When you're simplifying radicals, you cannot have a radical in your denominator. That's kind of one of the key skills we're going to be practicing in this next part. So for number 5, we're taking the square root of x to the 6, which is over y to the 8th. So what you're doing is you're taking the square root basically of each term. You have the square root of each one individually. So the square root of x to the 6, that's x cubed. Square root of y to the 8th, that's y to the 4th. Bingo, we're done. Okay, it's that easy, that simple. For the next one though, 4th root, so try to simplify what you can right now. That's what I would try to do. So since everything's underneath the 4th root, I'm taking the 4th root of everything individually. Try to see what you can simplify. You might not have to do as much work as you think. So 4th root of 16, that is a perfect 4th root. That comes out to be 2. You cannot take the 4th root of 9 though, so I'm just going to leave that 4th root 9. But I know I can take the 4th root of x to the 4th. That's just going to be an x. Okay? But like I mentioned earlier, you cannot have a radical in your denominator. Okay, so now we have to actually start rationalizing our denominator. And how you get rid of a radical down below is you just multiply by it. So if I want that 4th root of 9 to go away, I want the radical to go away altogether, I'm just going to multiply by the 4th root of 9 as many times as it takes until that radical is gone. Okay, so we're used to square roots where you only have to multiply by itself and then it's pretty much done. But with a 4th root or cubic root, you might have to multiply it out 4 times or 3 times to get rid of that radical. So let me just translate it down here. Okay, here's what we got so far. And again, I'm just going to multiply by the radical, 4th root 9, 4th root 9. When you multiply right now, what you would have is you would have 2 4th root 9 over x. This would be the 4th root of 81 when you multiply these two together, which I know, obviously because I'm a math teacher, I know that I can take the 4th root of 81. So again, you're only going to multiply as many times as it takes until it fully simplifies. I know I can simplify the 4th root of 81. If you type this in, 4th root of 81, it should be 3 in the end. Okay, so my final answer, I'm done. I can just stop right here. Again, all I was trying to do is just get rid of that radical in the bottom. So now my final answer, I can write it out as being 2 4th root 9, so that's on top. On the bottom, this would just be a 3x, because again, I take the 4th root of 81, that's just 3. We already have x simplified, so there's my final answer. Okay, and the next one, square roots. So again, simplify what you can right now, and then we'll deal with, if we have a radical left in the bottom, we'll deal with that when the time comes. Okay, so if I simplify right now, square root of a to the 9th, again, how many groups of 2 can I pull out of 9? I can pull out 4 groups of 2. And I'd still have an a left over. Okay, I'm not so concerned about that. The problem is the bottom. Taking the square root of b to the 5th, I can take out 2 groups of 2. I'm still going to have square root of b. Okay, but I can't have a radical in the bottom. So what I'm going to do, I'm going to multiply by the square root of b until it's gone. So if I just do it one time though, that should realistically be enough. We should be good to go after this. So after just the one time multiplying by the square root of b, you would have a to the 4th, square root ab, that's on top. So I already have square root of a, so now I'm timesing it by the square root of b. On the bottom, we would have b squared. And again, when you multiply these together, that's the square root of b squared, when you multiply those two. Well, square root of b squared, we know is b. So I have times a b on the bottom. So if I clean this up, my final answer would be a to the 4th, square root ab. On the bottom, you would have b cubed. And there's your answer. Okay. Last one, number 8. This is going to be the messiest one that we got because nothing simplifies. You have the cubic root of 3, which you can't do that. Cubic root of 4, can't do that. Cubic root of y, can't do that. Okay, so this one, what it's going to take for this one, let me just even combine this back together. So we have cubic root 3, cubic root of 4y in the bottom. Okay, it's going to take 3 times multiplying out cubic root of 4y until we have that radical completely gone in the bottom. So here's how this one's going to work. We already got cubic root 3 on top. All right, cubic root of 4y. Again, it's going to take this many times multiplying it out in order to actually get rid of that radical altogether. Because when you just multiply by the one time, cubic root of 4y, cubic root of 4y, where you're at right now, if you just multiply it by itself one time, this would be 16y squared. Well, 16 is not a perfect cube, and neither is y squared, so that's not going to do anything. So I still have to multiply by itself one more time in order to completely wipe out my denominator, in order to get rid of my radical altogether. Because right now what you would have, so if I multiply this all together, on top, what we have, so when I multiply all these cubic roots together, we have 3 times 4, so that's 12, times 4, so that's 48, y squared, over, so now on the bottom, again, when you multiply all 3 of these together, technically that's a cubic root of 4 times 4 times 4, which is 64. And then y times y times y is y cubed. Well, all of that simplified, if you take the cubic root of 64y cubed, that's just going to be a 4y. Okay, but we're still not done. Because on top, what you could do, extend this a little bit, so hopefully you guys haven't run out of room yet, but cubic root of 48, we can simplify that. Okay, I can break that down. The cubic root of 48, can't do anything about the y squared, so that's still going to be underneath the radical, but I can break down 48. I can simplify this more. Okay, so what do I mean by that? So let me do the prime factorization. Breaking down 48, 2 times 24. That's 2 times 12, 2 times 6, 2 times 3. Okay, cubic root, you want groups of 3 of the same. Here's a group of 3 2's, right? I want a group of 3 of the same number. There's 3 2's, which will come out front as a single 2, and then we still have these guys left over. So how this simplifies, if I take this final answer, this would be 2 with a cubic root of 6y squared. So again, I'm just multiplying the 2 and the 3 that's left over back together. So it's a 6 underneath. This will be all over 4y. The whole point of doing that is now you can actually reduce down your answer. The 2 and 4 out front, that just reduces down to being 1/2. 2 over 4 is 1/2. So my final answer after simplifying, after reducing, would be cubic root of 6y squared all over 2y. There's your final answer. Okay, so all these rules coming together all at once, you want to keep simplifying, simplifying, simplifying until you can't do it anymore. Okay? On to the next page. Now we're multiplying with radicals. So when you're multiplying with radicals, the key thing is that you have to multiply the same radicals together. So you can only multiply a square root with a square root, cubic root with a cubic root, so on and so forth. Okay, but you do already have these numbers out front, so take this into account. Again, we're multiplying these together, so I'm going to multiply the numbers out front together, 5 times 3, and then everything that's underneath the cubic roots gets multiplied. So we have over here negative 12 ab to the fourth times 18a squared b squared. Okay, so let the multiplying begin. We would have, so 5 times 3, that gives me 15 out front, cubic root. So now I'm multiplying negative 12, 18, that's negative 216. A times a squared is a cubed. B to the fourth times b squared is b to the sixth power. So remember your laws of exponents. If you have a multiplication problem, you just add the exponents basically. And now take the cubic root of negative 216, a cubed, b to the sixth. So again, if you break this up, just take the cubic root of each term. This would be 15, still out front. Okay, starting to simplify, the cubic root of negative 216 is negative 6. A fully simplifies, the cubic root of a cubed would just be a, and then cubic root of b to the sixth would be b squared. Now we got to multiply 15 times negative 6. So my final answer, fully simplified, comes out to negative 90, and then we'd have ab squared. There you go. So similar idea for number 10. Again, the numbers out front get multiplied, 6 times 4. And then square roots get multiplied. So we have 8c cubed d to the fifth times 2cd cubed. So we got 24 out front. Underneath the square root now, 8 times 2 is 16. C would be to the fourth, D would be to the eighth. And now simplify the square root. Take the square root of each and every single term from left to right. So you'd have 24, square root of 16 we know is 4. And then we'd have C squared, D would be to the fourth. And now last but not least, just multiplying 24 times 4, so that's 96. C squared D to the fourth. Here's your final answer. All right. Moving right along to the next one. So now we're adding and subtracting with radicals. Key thing here, you have to have like radical terms. So what are those? What's a like radical term? Here's an example. I can only add, like if I had 5 square root 3, I can maybe add to it something like 7 square root 3. Basically, the radicals have to be the same. Okay, that makes it, that's going to constitute as being a like radical term. The radicals are the same. So if you add these two together, it's going to come out to be, you're just really adding the coefficients, 5 and 7, you get 12 square root 3. So same or similar idea, like if you had 5x plus 7x, same idea. That's just going to be 12x would be your answer, not 12x squared. So the x stays the same. Same idea. The radicals stay the same. Square root 3 and square root 3 do not change. It's not now the square root of 6. You keep the square root the same. You're just going to add the coefficients. Okay? So for 11, we got to make these into like radical terms is what we're trying to do. So we need to simplify each radical. So let's see, 98 as an example. I'm going to break this up. I'm just going to do 49 times 2. 49 times 2 is 98 because that's the quick and easy way to simplify it because I know square root of 49, that's just 7. So that's 7 square root 2. Okay, then we're subtracting away from this 2 square root 32. Break down the radical. I'm just going to do 2 times 16. Again, because I know square root of 16, that's just 4. So that's 4 square root 2, but you already have this 2 out front. This 4 is joining that 2. When these come together, you got to multiply them. So 2 times 4 makes that 8 square root 2. So here's our real problem. 7 square root 2, we're subtracting from it 8 square root 2. So I'm really just subtracting 7 minus 8. I get negative 1 square root 2, or just simply negative square root 2 be my answer. Same idea for number 12 for the next one. So simplify each radical. I'm going to break up 8 to be 4 times 2, because I know the square root of 4, that's 2. So 2 square root 2, but again, this 2 is joining the 4 that's already there. These get multiplied. That's 8 square root 2. So there's my first term. And now I'm going to add to this 3 square root 50. Well, 50, I can just do 25 times 2, because 25 square root, that's 5 square root 2. Okay, but the 5 now is joining the 3 that's already there. So 5 times 3 makes this 15 square root 2. Now we can add these two together. They're like radical terms. They have the same radical, square root 2, square root 2. So 8 plus 15 is really all I have to do. That's 23 square root 2. Final answer. So for the last one, 12, I'm just going to break this up into, the easy way is 4 times 3, because the square root of 4 is 2 square root 3. Again, 2 is joining the 5, so that makes this 10 square root 3. Okay, so there's our first one. The next one, breaking down 27, I'm just going to make this 9 times 3, because square root of 9 is 3. So we have 3 square root 3, and again, the 3 is joining the 2 that's there. So we'd have plus 6 square root 3. Multiplying the 3 times 2, and now breaking down square root of 128, I'm just going to break this up into 64 times 2, because the square root of 64 is 8. So that's 8 square root 2. And there's no number in front of the radical, so this is just simply going to be minus 8 square root 2. Okay, so we only have 2 like radical terms that we can actually do anything with, just the square root 3's. So I'm just going to add these two together. Final answer would just be 16 square root 3 minus 8 square root 2. There's your final answer. All right, so we got multiplying up here, adding and subtracting, more multiplication on the next page. So when you're multiplying, almost kind of looks like 2 binomials together, with radicals involved though. So when you're multiplying these together, you got to FOIL it. Foil these two together. But take your time when you FOIL. Okay, it could be kind of messy in this case because even when you start with the first one, right? If I do 4 square root 3 times 3 square root 2, you're multiplying 4 times 3, but you're also multiplying square root 3 times square root 2. So that would be 4 times 3 makes that 12, and that'd be square root 6. Okay, so when you're multiplying radicals, you're going to actually multiply the numbers underneath the radicals together. So now when I expand this to the outside, so 4 square root 3 times negative 6, that's going to be a negative 24 square root 3. So I'll pause, make sure that makes sense. I just multiplied really 4 times negative 6 with the square root of 3. Okay, my inner term now, multiplying these two together. So 5 square root 2 times 3 square root 2 makes that 15 square root 4. Okay, now the last one, 5 square root 2 times negative 6, that's going to be negative 30 square root 2. All right, let's go back here. Let's backtrack a little bit. All we can really do, simplifying wise, is take care of the square root of 4, because we know what the square root of 4 is, that's just 2. So we're going to have 12 square root 6 minus 24 square root 3 plus, that's technically 15 times 2 minus 30 square root 2. Last thing I can do is just multiplying the 15 times 2. There's no like radical terms even after multiplying. So from left to right, I'm just going to copy my answer. You can leave it in this order too. You don't have to arrange it really a different way. I'm just going to leave my answer like this. Okay, there's no like radical terms, nothing more I can do. That would be it. So for the next one, foiling. So 6 square root 3, 2 square root 5, that makes this 12 square root 15. All right, double check my math. 6 times 2, square root 3, square root 5. Okay. The next one is going to be 24 square root 6. So again, 6 times 4, and then multiplying the radicals. Square root 3, square root 2. Inner. So these middle terms here, those ones in the middle, would be minus 10 square root 5. And the last ones that we have would be minus 20 square root 2. And once again, it looks like I have no like radical terms. Nothing simplifies. You can't break anything down further. Square root 15, although it looks kind of big, that does not simplify anymore. 6 doesn't, 5 doesn't, 2 doesn't. This would be my answer. Okay? But you want to check and see, do you have any like radical terms? Can I actually break anything down or combine it together? In this case, you can't. And the last one, if you had to rationalize a denominator that's a binomial, so like square root 5 minus 1, think conjugate. You want to multiply by the conjugate. So there's an example here what conjugates are. If you have 6 plus square root 2, the conjugate is just 6 minus square root 2. Okay, so if I want to rationalize my denominator, again, I just basically want to get rid of the radical on the bottom. I want that square root of 5 to go away. So in order to do that, I'm going to multiply by the conjugate, which is square root 5 plus 1. But I have to multiply the top and the bottom by that as well. Okay, so the whole entire fraction is changing. The top, the numerator, and then also the bottom, my denominator. So on top, when you multiply your numerator 2 times square root 5 plus 1, distribute to both terms. So that's going to make this 2 square root 5, and that's plus 2. On the bottom, though, you have to FOIL these two together. So as I start multiplying by the conjugate, this would be square root 25. This would be plus square root 5 minus square root 5 minus 1. Okay, so I did the multiplication. Multiply by the conjugate. Now to clean this up, on the bottom, those obviously just cancel. Okay, on the bottom though, square root 25, that's just 5. On the bottom, all I really have is just 5 minus 1, and that's 4. So I'm going to have 2 square root 5 plus 2 all over 4 is my answer. Okay, technically that is my solution, but you can reduce this. So this 2 out front, the 2 and the 4, I can divide everything down by 2 to make this the square root of 5 plus 1 all over 2. There's my final answer. Okay, same thing for number 17. To get rid of that radical on the bottom, the square root of 2, I got to multiply by the conjugate, so 5 minus square root of 2 on the top and bottom. So on top, distribute to both terms. Negative 3, so that makes this negative 15, plus 3 square root 2. Bottom now, my denominator, again, foiling these two together, we'd have 25. This would be minus 5 square root 2, plus 5 square root 2, minus square root 4. Okay. So where we're at right now. Again, on the bottom, these just cancel in the middle when we FOIL. On the bottom, we got 25 minus the square root of 4. Well, that's 25 minus 2. Square root of 4 is 2, and that's just 23. So where we're at, we have negative 15 plus 3 square root 2, and that's all over 23. No reducing necessary here. Nothing you can actually reduce down. That would just be it. Okay, and this concludes our lesson for today. So hopefully you feel like you learned a little something. Come back and visit this video anytime. Again, if you have questions, just let us know. Thank you very much.